This is Mission Control Houston now with a live view inside the Space Hab Research Double Module. It's the laboratory for the STS-107 Space Shuttle mission. You can see Payload Commander Mike Anderson working inside the lab, and also Mission Specialist David Brown is adjusting the camera for our view. Anderson is working through a procedure to gain access inside the combustion module that is housing the laminar soot process experiment. Brown will be conducting another run of that laminar soot process experiment later, and Anderson is working on preparing the module for that experiment. The combustion module 2 provides experiment control, containment, diagnostics, and communications for on-orbit fire-related experiments. Currently, the hardware for the laminar soot process experiment is placed inside the module. Later during the flight, 2 other experiments will be put inside the combustion module for runs with those experiments.
Here we're seeing live downlink of this experiment run on the bioreactor. The bioreactor, as you perhaps can see on this live downlink on NASA television,
Copy, Alon. Thank you very much.
Bioreactor is shown as it rotates. It contains a growth medium for cell cultures, and in microgravity and by rotating it allows these cell cultures to grow in 3 dimensions, much like they grow in the human body, as opposed to the 2-dimensional cell cultures that we see on the Earth's surface when they're grown in dishes.
Columbia Space Hab talk. For Laurel, no need to respond, but BDS-05 just wanted to let you know that they are capturing this video and they think things look very good.
Okay, great, and I'll push record up here as well.
Copy.
Positive words from the scientists on the ground focusing on the BDS-05, the bioreactor demonstration system. These cells that you can see, the white clumps in the growth medium inside the rotating bioreactor, are related to a study of prostate cancer. They're prostate cancer cells and bone cells, and the object of this particular experiment on the bioreactor is to try to determine or to better understand how prostate cancer spreads into bones, and perhaps with that understanding produce better treatment methods in the future.
Yes, we can hear you loud and clear now.
We can hear you now, Columbia, and we can see you. I will pass the question to the Prime Minister of Israel, Mr. Ariel Sharon. אדוני ראש הממשלה, בבקשה.
Prime Minister.
שלום לך.
Lan, shalom to you.
שלום לך, אדוני ראש הממשלה.
Shalom to you, Mr. Prime Minister. 5 days ago,
ערב המראתך,
just the evening before,
היינו מאוד נרגשים, שרת החינוך ואני, שהייתה לנו הזכות לדבר איתך. עכשיו, אנחנו רואים אותך שם, אנחנו נרגשים עוד יותר.
אני חושב שאני נרגש לא פחות מכם, בוודאי, לשוחח איתך, אדוני ראש הממשלה, ועם החינוך, אבל במיוחד לשוחח אתכם מכאן, מהחלל.
הייתי לדעת, אתה רואה שם,
what can you see from there that we can't see from here?
אני אספר לך,
I will tell you
מה שרואים מכאן,
that what we can see from here is amazing. Our Earth, the planet, is beautiful. It really is beautiful. But what is more interesting is that the atmosphere is extremely brittle, and that which enables us to breathe and live is very brittle, very thin layer, and it's slightly bluish during the day, and during the night, when you can see a kind of reflection from that atmosphere, and we just have to safeguard it with all our hearts. I sincerely hope that the experiment that you're carrying out will most specifically contribute to this target of maintaining it. Did you have a chance to see those desert storms? At the moment we have got rain falling, blessed rain.
Mr.
Prime Minister, unfortunately I could not quite hear everything you said. Could you please repeat what you said? We heard what you said, and what you said really commits all of us. You managed to see sandstorms, but here, at the moment, rain is falling upon us. True, blessed rain. And I hope that those experiments that you're performing with your crew members will contribute to safeguarding Earth. Unfortunately, I couldn't hear the first part of what you said, but our mission here is a scientific mission. We have got 10 experiments to perform. We're working round the clock, more than 16 hours a day, every day. We speak a little bit as well. We've got to leave hardly any time to go to look out of the window and enjoy it. And the short period of time that we do have is plenty, and the other members of the team that are with me and those that I have trained with, and lived with them for 2.5 years, they are incredible, a wonderful team of people, and we feel as if we're at home. And that is not only assisted by those that are with us, but much more so by the team, the incredible team, extraordinary team of the supervisors and our trainers and all those who are watching us from France. Ilan, if you could possibly tell the commander, the cousin, and that wonderful team with you, our congratulations and our blessings from Jerusalem. People for 3,000 years and for eternity.
I will most certainly pass that message on, and they would definitely also like to come to Jerusalem as they are planning to visit Israel after the flight, because everyone loves Israel, and they love us, and we love them. I would like to thank you from here, from Jerusalem, to the President of the United States of America, President Bush, and the previous President of the United States, President Clinton, who then had decided to send one of our space astronauts to space, NASA. I would like to thank NASA as well and all those who have exerted efforts to bring us to this achievement, and I hope it is just first one amongst all our flights into space. If you will permit me, I would like to second every word that you spoke, and all those greetings and congratulations. But more than anything, I would like to, as a token of thanks, to thank Eitan Ben Eliyahu, the previous commander of the Air Force, because without him, I don't think that we could have reached what we have. And we have Evan, and the Israel Space Agency in Israel, and Professor Yuval Neilan, who founded it, and the Ministry of Science, who has been supporting us along the path. And an additional, maybe word of thanks to our scientists who are working in Washington, just beside us, with us, coinciding. And they're doing some very successful work, and everyone here is involved in that experiment, and I would truly like to congratulate that team of scientists. Thank you very much.
and my best wishes for your success. Ilan, this is Limor Livnat. I'm delighted to speak to you in space, and this is being transmitted to all the different channels in Israel, and everyone can see you. And I would like to congratulate you. It's an immense excitement, and I would like to ask you, and it was sort of publicized in Israel, that you took with you to space on your journey certain objects that have Jewish historical symbolism. Could you tell me what you took? Thank you. Hello, good afternoon to the Minister of Education, and I'm delighted to speak to you and to all the audience. Yes, I did take certain things with me that are extremely significant from the point of view of the heritage of the people. But before I actually show those objects, I would like to say that from here, from space, Eretz Israel looks just as it does on the map, small but charming. And I think that Am Yisrael, the people of Israel, is a wondrous people, and I believe that we have truly extraordinary people in Israel, each and every one of them, and I think that it is very important to cherish our historic and religious heritage. And now I would just like to say a few words, and I would like to present one object that I received special permission. We're not normally allowed to show these objects, but I think that this is a very moving object, and I'm even touched and moved when I hold it in my hand. It is a Torah book, tiny little one, as you can see. It's about 60 years ago, a young child in the Bergen-Belsen concentration camp. He saved it from the rabbi in Amsterdam after he'd been teaching him, preparing him for summit, and this 13-year-old child read out the parasha of the week, the portion of the week from that scroll that, as you can see, was tied up in a little handkerchief, and it was in his handkerchief from that time onwards. He was survived with so much luck, and he managed to immigrate to Israel, and he fought in the different campaigns and wars of Israel, and has now become a distinguished professor at Tel Aviv University. That is Professor Yoachim Yoya. That today is one of the chief Madex scientists, the experiment that we are carrying out here, the Madex experiment. So you can see that this is a bond that ties the state of Israel to what is happening here in space, and I would like to thank him deeply, because I'm extremely moved that I have it with me here in space, because I think that that represents more than anything the Am Yisrael, the nation of Israel's ability to survive despite everything, from horrific periods of time, from dark and dismal days to days of hope and a glitter of a future. I would like to thank you very deeply, and the fact that there in space you're holding on to that scroll that survived the Holocaust, and this intermingling with the heritage and Professor Yoachim and what it symbolizes with cutting-edge technology, I think it's the perfect blend, and that's what we need in Israel, the heritage, history, and I think that you're doing it in a remarkable fashion. And there's a whole group of children here, pupils, and I would just like to tell you just one more thing. And to the commander of your mission, Rick Husband, and the entire team, I would like to understand you would love to come and visit Israel. And this is an invitation to the team to come and visit Israel, not only from the States, but we have an opportunity to see Israel not only from the States. I'm very proud, we are very proud that Peter Ramon is with you, and I'm personally very proud that two women are part of the team. And this is another issue that I'm very much, I really feel I'm very happy. So you are invited, all the team, not only the four of you, but all the team invited to Israel, to Jerusalem.
Well, we certainly do. We've been talking about for a long time during our training bringing forward to, and we will certainly be looking forward to that after our flight, and looking forward to a visit to Jerusalem and also to see you and all the other fine folks there.
Looking forward. אני רוצה לברך, כמו שאמרתי קודם, תלמידי כיתה ט' במכללה הטכנולוגית,
Pupils from the technology school in Gilo, and Tyson Honey, our representative, would also like to ask Colonel Ilan Ramon a question. Shalom to you, Ilan. Right here with 4 other representatives from Earth, from planet Earth, and from the comprehensive school in Gilo, Jerusalem. And we wanted to ask you numerous questions, but unfortunately we were only allocated one. So what is the most significant and unexpected experience that you've experienced up to now? And is there any link between that and the fact that you are Israel, or did the other members of the team also experience that feeling?
שלום לכם סטודנטים ותלמידים
students and pupils, and all our audience, even those who aren't watching us at this moment but are in Israel. I think, as an answer to your question, I think it's the most moving and special experience beyond just looking out of the window, is the fact that God is floating. You can't actually see us floating at the moment, because we're just watching the camera, but this condition of floating when you go to the example, and at the same time I'm actually floating, because I'm floating and what the predictions and visitors used to tell us, that's what's happening here, and we are amusing ourselves with this project, and it's absolutely charming. And this is where the people and our education inspired. And Prime Minister, we have an experiment here. I haven't had the chance to see it myself, but I think it's working well. And I think that that's one remarkable way of attracting our people like science and to explore things and to look with a vision into the future. Well, unfortunately, not much time is left, but Professor Yuval Ne'eman is with us, and I'm sure he'd be delighted to talk to you, Colonel Ramon. Ilan, hello, shalom. And I sincerely wish you all the greatest success with this Israeli dream. You mentioned those days 40 years ago when I did create the first framework that dealt with space with Professor Yoachim. He was one of the first who I mobilized to join me in that first department. I have just 2 requests to ask you. If you have any time to ponder and think and see, participate with responsibility, with accountability, the generation that's coming and going. You have to think about how to be at the helm and persuade the Israeli government and public how to advance and promote the whole topic of space and work, not only contributions that will just be sort of lagging behind others, but that will lead. And from a professional point of view, I would like you to ponder on the question, how are people, or how would you be able to really soothe people when we're talking about journeys that could take years, just as once upon a time when you could go out on a boat for excursion that lasted 5 years. So here also, to depart on excursion, for example, to Mars, it could take 5 years. So for the moment, I hope you enjoy this mission, and maybe even the Mayday results will also be interesting. And all the best. Thank you very much, Yuval. And to your second question, yes, I think we already have numerous answers. And thanks to the 4 years, like you say, in NASA, up to now, we're still learning and studying. There's still much more to learn. And to your first question, if you are those at the helm and one of the most well-known and renowned, we have brilliant brains and minds for Israel, and I think that be our most significant contribution to space domain. I don't believe if we have to actually send other things into space, but we ought to use advantage those grants ready. Because this is something that should be, of course, taken advantage of. And we need resources for that. I would like to thank the Ministry of Science and the Director General, Mr. Leffer and Peter Proffer, for all they have contributed to the Deputy Director General, who is functioning as a lean host to this whole topic. Mr. Our Evan also has a personal message to you, as far as I know. Yes, 4.5 years ago, I was there when you were launched, and I hope I might even be there when you land, I'm not sure. But you have got very warm greetings and regards from your wife. I'm not sure if you had a chance to speak to her today, and I wish you a safe landing, and that we can continue cooperating and doing things together, and for the best of luck. Thank you very much, Abby, and thank you for all those efforts that you've exerted for this enterprise in the last 2 years. And although I haven't spoken to my wife, I did actually receive one email from her, because she hasn't told me it, but I would like to just say that Ronna and my children felt their support and all the concessions that they had to make along the path that they were difficulties. But they took that burden upon themselves, and without them, I wouldn't have managed to do any of this. I love you, Ronna. So that we've only got 2 minutes left, Ilan, and I think that it would be right that Prime Minister to summarize these last 2 minutes. Ilan, I will not exaggerate if I say that all of us, those sitting here together, and many other citizens of Israel, are somewhat envious of you and your ability to be where you are. I want to congratulate you for the way you have stood proudly for you and your belief is shining forth. And I also believe, as you do, in the abilities and the tremendous talent that we have here. And I truly believe that we are a unique nation that has survived so many hard attempts against us and can reach the zenith of abilities. We have the fortitude and the ability. And if we are determined to define what our aims are, and they are so important, I believe that we will be able to attain any achievement. And you are one of our great achievements. And I would now like to Commander Rick Hudson.
I'd like to invite you and the wonderful team that you are leading in Colombia to visit us here. I can assure you that you will find yourself among friends and will have the chance to meet the people here that you are working and helping in this trip that you are doing now. Again, I would like to thank you for everything that you were doing, for your friendship and understanding, and we are looking forward to meet you here in Jerusalem, the capital of the Jewish people, for the last 3,000 years. You are mostly welcome, all of you.
Thank you very much. We really appreciate the invitation, and if the people of Israel are as nice as Ilan and his family, we know that we will be expecting a very warm welcome when we come to visit Israel, and we will be looking very forward to that when the time comes. And we appreciate this opportunity as well to fly with Ilan on this mission, and also to work with the scientists on the MEDEX payload as well, and we send our best regards to them and to you.
This is Mission Control Houston. You're looking at a live view of the payload bay in the Space Shuttle Columbia. You're looking at the Freestar pallet where there are 6 experiments being done during this mission. In the bottom right corner of your screen, you'll see a silver canister with the NASA words on it, and that is the SEM experiment, the Space Experiments Module, which is holding 11 U.S. student experiments. The 2 canisters next to it are the CVX experiment, the critical viscosity of xenon, which is studying physical processes of microgravity.
NKC, that's an excellent view. We appreciate you setting that up so the CM2 folks can watch this deintegration.
Shuttle and the rest of the red team had a morning off, getting some well-deserved rest and recreation after spending 7 days in space. Shuttle has spent her afternoon working with the laminar soot processes experiment, removing that from the combustion module in preparation for doing the next set of experiments to be done in that module, the softball experiment.
Columbia for Osteo feed number 7.
As you can see from this video, it's much easier to get objects off the ceiling in space than it is here on Earth. The research double module is a pressurized aluminum habitat that's carried in the Space Shuttle's cargo bay. It's approximately 20 feet long, 14 feet wide, and 11 feet high.
Reading on knob D686, over.
The research double module is connected to Columbia's middeck via a pressurized access tunnel.
23 minutes with a knob D reading of 686.
On STS-107, the research double module is carrying approximately 7,500 pounds of research payloads.
6 days, 3 hours, 26 minutes, and the C reading was 443.
Space Shuttle Columbia orbiting the Earth over the South Atlantic Ocean, moving into orbital nighttime.
Well, good afternoon and welcome back to the Johnson Space Center for today's status briefing on the progress of the STS-107 mission aboard Columbia. With us today to discuss the mission and the scientific research on board are Phil Engeloff, the STS-107 mission operations representative, Dr. John Charles, the STS-107 mission scientist, Dr. Gerard Faith, the principal investigator for the laminar soot processes experiment, and Cindy Hutchins, the principal investigator for the vapor compression distillation experiment. And we'll start off with Phil.
Thanks, Rob. Okay, well, I'm happy to report today again that the orbiter and the crew are all doing very, very well. The crew are staying well on the timeline. They have a pretty high level of activity and they're pressing through their scheduled experiments and operations pretty much right on schedule. They're all in good spirits. Everybody seems to be doing real well. The orbiter also is doing great. We have no significant anomalies to report on the orbiter, no real changes from the report I gave a couple of days ago. And the only thing that we have of any significance to talk about is at this point an annoyance, and we think we're going to be around the corner on that. We have had a cooling problem with the Space Hab cooling system, and it's technically actually a problem with separating out condensed water. The cooling system is cooling okay, but in order to avoid getting a lot of condensed water under the floorboards back there, we've had to back off on some of the cooling to minimize the condensation, and we're in the process of a workaround. The Space Hab has a couple of pieces of rotating equipment that we call rotary separators. For those of you familiar with the orbiter, they're basically the same thing as the humidity separators. At home, in your air conditioner, when you pass the cold freon through your air conditioner and then blow air over that, any moisture in the air condenses out on the coils, drips off into a pan, and it runs down a drain somewhere in your house. In a similar fashion, when we collect condensation on the heat exchangers in the cabin by blowing air over cooling fins, that water collects, but it doesn't run off because there's no gravity. As a result, we draw that off with airflow, and by using a rotating piece of equipment, we centrifugally separate out the water and force that off into a tank and blow the air back out into the cabin. A couple of days ago, we had a problem with one of those rotary separators, number one, in that it was flooding and not pushing the water off into a tank. So we had to shut that rotary separator down and switch to the alternate rotary separator 2, which ran fine and collected the water in the tank. Subsequent to that time, we did have an electrical short which opened 2 of the 3 phases of circuit breakers that were ultimately powering that rotary separator. And since that period of time, we've been operating without the rotary separators working. As a result, we backed off some of the cooling by diverting the airflow so it didn't go over these coils. Since we couldn't make the water go into the tank without the rotary separators, we didn't want the water collecting under the floorboards. We've made a couple of configuration changes on the orbiter to try to compensate for that. Ultimately, the orbiter provides all of the cooling for both vehicles. We have the radiators on the orbiter payload bay doors that radiate the heat to space. There's Freon passing through those, and we have a heat exchanger that basically runs water through the coils, and then we run the Freon past those coils, and we run heat from the cabin into the Freon that goes out and gets radiated into space. So that water that we cool in the orbiter gets pumped back into the space hab and provides the chilled water that ultimately is used to cool the cabin air back in the space hab. Without the capability of the water separators, we're doing what you might do in your house if you had an upstairs air conditioner and a downstairs air conditioner and one of them wasn't working. We've turned that one off and we're blowing cool air from the orbiter back into the space hab. We always have some amount of air exchange between the 2 vehicles, but to compensate for some of the degraded cooling, we've turned the temperature control in the orbiter down, so to speak, to chill that air somewhat more than normally, and then we're flowing that air back into the space hab to provide the compensation for the loss of cooling back there. We're in the process of trying to implement a short-term fix, or a quick fix, I should say, by adjusting the amount of cooling water that flows to different parts of the space hab to provide more cooling to some of the equipment racks in order to allow us to keep all of the experiments operating. And even though the air temperatures are a little bit warmer in the hab right now than they would normally be, it's really not a factor for the crew. It's really not even outside their comfort level. And until we told them initially that we saw the temperatures rising, they hadn't even realized that the temperatures were going up in the hab. So we think we have the temperature problem essentially under control. We do have one experiment that was affected by the loss of cooling. We lost one data take on an experiment today. With this fix of adjusting the water flow, we expect to be able to operate that experiment tomorrow, and we don't believe that there's going to be a loss of science by the end of mission. We think we'll have recovered everything. But that's really the only issue that we've got to talk about in terms of orbiter or space hab systems, and as I say, at this point, it doesn't look like it's going to be an impact to science over the duration of the mission. So I guess that's basically all I've got to say. I'll pass it over to Dr. Charles.
Thank you, Phil. The scientists supporting this mission are very happy with the productivity and the results coming out of this mission so far. We're only just getting started, lots of time left. We're going to be hearing from several of the scientists over the course of the rest of the mission during these briefings. Today we have 2 with us, Dr. Jerry Faith of the Laminar Soot Processes Investigation, and Cindy Hutchins, who'll tell you more about the vapor compression distillation investigation. Before they speak, let me give you a brief synopsis of the rest of the NASA Code U, that is the Office of Biological and Physical Research Investigations, over the last day or so. Yesterday, one of the fundamental biology investigations, the BRIC payload completed the first of 11 chemical fixations of moss samples. The moss samples are being studied for their sensitivity to environmental factors, and specifically their growth patterns in the absence of any environmental factors, in the absence of gravity, in the absence of light.
and so forth. The moss samples had been exposed to a directional red light up until 1 day after launch, and now they're growing without stimulus. We're hoping to see if they duplicate their behavior in STS-87 when they grew in a spiral. All of them uniformly grew in a spiral. The first fixation of moss samples was yesterday. Subsequent samples will be fixated every other day or so for the remainder of the mission, out to day 14 or so. So that experiment is progressing very well. The rodents on board are doing very well in flight. 2 other fundamental biology investigations haven't begun yet, but we'll be telling you more about those when they do start. In the area of human life sciences, the so-called medical experiments on board, the payload crew has completed the first go-around, the first 6-day go-around of blood and other body fluid collections as part of an investigation to understand how proteins, how the body's muscles and the body's bone and calcium stores and other parameters change with time and flight. 5 blood draws were accomplished, and all 4 payload crew members and 2 tracers were injected in the 4 payload crew members. All 7 crew members are doing daily saliva collections for us to understand how the body's immune system changes in flight. And they're logging with the barcode reader their food and exercise daily activities. So the payload crew will continue with their frozen and their ambient saliva collection. Some of the salivas are collected and frozen, some are just stored in a pouch in a location in the cabin. And the orbiter crew concluded their urine collection today, but the payload crew will continue with that as well over the remainder of the mission. Yesterday, another human life sciences investigation had a slight setback. There's an experiment named Microbial Physiology Flight Experiment, and it's a modification of a commercial piece of hardware. One of the card trays jammed in the reader yesterday, and it took so long to get it unjammed that the specimens on the card tray were considered lost because of exposure to ambient temperature. But there are 6 card trays during the mission to be collected during the mission, and the 5 remaining should give practically all the information required. So the experiment will continue with the incubation and the analysis of subsequent card trays. Our sleep study is continuing with nominal operations. In the area of microgravity sciences, we'll hear from Dr. Faith in just a second about the combustion module experiment to laminar soot processes, but the investigation looking at compaction of simulated soil mechanics of granular materials has completed 5 out of 9 runs so far for the mission, 5 out of planned 9 runs, with a 6th run planned for later today. They are on timeline and progressing very well. And the bioreactor, the biotechnology demonstration experiment that is running, you may have seen the rotating vessel on some of the NASA TV earlier today, is going very well. The cells are accumulating and clumping spectacularly. Its growth that seems to far exceed growth that is found in similar cultures on the ground. So we'll be telling you more about that as the mission progresses. The other microgravity science experiments are progressing all normally today as well. So that concludes the brief overview of the basic and applied sciences in the NASA allotment. I'd like to turn it over now to Jerry Faith to tell you about one of those investigations, the laminar soot process investigation. Jerry?
Thank you. Tests carried out by the astronauts on Space Shuttle Columbia over the last 5 days really have provided very valuable results, and have exceeded all my dreams for what we could get. In essence, we've been preparing for this flight for 6 years. I sort of feel like a prize fighter that's trained for 6 years and has finally won the bout. I'd like to tell you a little bit about what we've found out and why it's significant. First of all, let's define some properties of soot in flames. Soot really is small carbon particles, and when these carbon particles are hot in the flame, they glow yellow, and that gives the characteristic yellow color that we're all familiar with. When they come out of the flame, they yield up a black plume that is also a familiar sight when you observe soot-emitting systems. Soot particles are small. They take about 1,000 soot particles to go across the diameter of your hair, for example. Unfortunately, they readily deposit in lungs and during breathing, and that makes them a possible source of health problems. In fact, soot is widely recognized as a bad-smelling and irritating pollutant. And in fact, it really causes more deaths, 60,000 a year in the U.S. alone per year than any other pollutant that we know of. LISP experiment itself involves exploring several ideas. First of all, typical practical flames, for example, a campfire or something you might see in your fireplace, are turbulent. That means they're very unsteady and they flicker. And they are really little affected by Earth's gravity. So therefore, due to the unsteadiness and the like, studying soot in practical flames is not feasible. In particular, very poor spatial resolution for measurements, and you need lots of measurements to learn anything about soot. Studying soot in a steady, non-turbulent flame like in Earth's gravity, like a candle, seems like a very obvious step. But in fact, it turns out to be very misleading in trying to get to the fundamentals, and I think studying candle flames has had a lot to do with our rather slow progress towards studying the production of soot in real flames. On the other hand, if you can observe soot processes in steady, gravity-free, non-turbulent or laminar flames, flames that have smooth surfaces like candles, those kinds of measurements are both feasible and appropriate as model flame systems for practical flames. And that's what our interest in these flames is motivated by. Thus, the objectives of LISP are to observe the properties of gravity-free, soot-containing laminar flames, and to determine whether these flames provide good models of practical turbulent soot-containing flames. I believe they have some an example of one of our tests, and if that could be run now, I'll give you a better idea of what we're talking about. This is the start of the experiment. This is an igniter wire that comes in as the burner is on the left, and you can see the flame coming out and growing. Now the operator along Ramon gradually increases the velocity of the flow to achieve a fairly large flame, as you see. You could never see a flame like this on Earth, so you're seeing something that no human being has really ever seen before. But you can see it's large and spread out, and it's steady or stationary, and it'll be the same from month to month, and provides an excellent test bed in which to study the properties of soot. To go on, the main findings of the experiments this week are, first of all, the measurements show that soot processes in practical turbulent flames are correctly modeled by these gravity-free flames that I've just shown you. They also clearly provide a large and slow-moving laminar flame that's tractable for the detailed measurements you must make to study soot. Thus, future experience involving gravity-free flames should provide rapid gains in our understanding of this public health problem, the generation of soot in flame environments. In fact, recent work exploiting earlier LSP findings from earlier flights have disclosed ways to eliminate soot in practical turbulent flames entirely, converting them to blue flames or soot-free flames. Upcoming flame experiments on the International Space Station, a series of experiments called SPICE, S-P-I-C-E, will seek to confirm these findings for gravity-free laminar flames. Thank you.
And next to last, Cindy, you'd like to tell us something about the vapor compression distillation investigations.
Thank you. Good afternoon. The vapor compression distillation flight experiment, or VCD, has successfully completed 3 days of operation. We're very happy about that. We've been getting good data downlinked to us, and so far it looks like what we expected to compare the data to the ground data. The vapor compression distillation flight experiment is a similar system to what will be used on the space station to recycle the crew's urine into potable water. So this is very important to get our data to make sure that there are no microgravity issues with that operation. The vapor compression distillation flight experiment takes water, it evaporates it at a low pressure, and then condenses it, and then the clean water is pumped out of our system, and all the salts and other things left in the urine are collected, and then they will be returned to Earth when it's used on the space station. So we feel like this is going to be a great improvement to the space station because the crew and the shuttle will not have to take up so much water. It's going to greatly reduce the amount of water that has to be lifted to the space station, and it will help the crew to have good drinking water.
Thanks, Cindy. And we'll take questions here in Houston. Before going down to the other centers, please state your name and affiliation. We'll start with Mark.
Yes, I have one for Dr. Hutchins and then a couple other questions. The experiment of recycling the water, is there sort of a rough time frame when this technology would mature to the point it could be on the space station? Are you aiming for a certain period of time?
Yes, we are. We're right now developing our hardware. We're building hardware to send up, and it looks like our schedule right now is 2006. Yeah.
And just to follow up on that, is this hardware then that you would use as a prototype on the space station for an advanced spacecraft that would travel in interplanet? I mean, I just wonder where this is really going in a development sense beyond the space station.
Yes, this will definitely be useful for long-term space flight. There are also some ground uses that it could be used in remote areas where you need a very small system. We've built our system very compact and very lightweight so that it could be used in space, and this would be very important for longer-term space flight. And I believe that the use on the station will prove that that's going to be a very good use of the hardware.
Okay, thank you. And I had a couple for Phil and Goff on the humidity separator. Can you kind of lay out what your strategy is in the sense, are you in a position where you need to repair one of the two separators in Space Hab, or would it be possible to sort of manage this problem as you are now throughout the extent of the 16-day mission? And I guess somewhere in both of those questions is for you to gauge, can you make the whole mission if this is a problem you can't fix?
The simple answer is we're optimistic that this little bit of diverting water from one loop to another, one part of the loop to another part of the loop, will actually get us to a configuration that we could live with for the rest of the flight. That's the simplest way to solve the problem, and that would be our preferred method. To be just a little more elaborate than I was in my original description, the water that comes back into Space Hab from the orbiter cooling provides a couple of different purposes. Indirect cooling in the sense that we blow air over it to chill the air and use that for ambient cabin atmosphere cooling. We also run some of that water over other heat exchangers and then take some of the water that's cooled by those heat exchangers and run those through the payload racks to keep the experiments cool. We're operating in pretty much a stable configuration right now, but some of the payloads that require a higher heat load, like VCD, for example, running in conjunction with all of the other experiments, we really need a little more heat rejection capability. So part of what we're going to do is to try to divert a little bit more of the water to the racks in order to cool the experiment loop so that we can run all of the experiments. And we think we've already got the cabin temperatures under control in a livable condition. So if we can solve the heat rejection for the payloads, we think we can fly the rest of the mission in that configuration. A more aggressive solution would involve trying to repair one of the two water separators. One of them we think flooded, like I say, and we think that might be due to blockage, and we'd have to dry that out and resolve the blockage if that turns out to be the problem. The other one we think was an electrical short. We don't know exactly where that is. We'd have to go in and do some troubleshooting and try to find out where the short was. If that was due to residual water, maybe we can clean that up. But we always prefer not to go in there and try to repower equipment that's had a short on it if we can avoid it. So the first solution is really the preferred option.
Okay. Questions now down at the Kennedy Space Center.
Hi, this is Chris Kreidler from Florida today. My questions are, I have a couple questions for Cindy. How much energy does this recycler use? It's not just like flushing a toilet, it sounds like.
This is a phase change process, so it is fairly energy intensive. But compared to the amount of water that you would have to lift, it's still a very good solution for for recycling, for taking water up to the crew. But it is a more energy-intensive process than, say, a filter would be, because it does change the water from liquid to steam and then back to water. So it is a fairly energy-intensive operation.
Is this something that could also be adapted for Earth use, say, an expedition in Antarctica or something like that?
Yes, I think that would be a very good use for this equipment. The Navy has talked to us about using it on submarines. Any small remote area where you would need clean water could use this system. Ours is fairly expensive because of the materials it's made out of, and we have to get it into a really small area, but it could be enlarged or other materials used that would not be quite as expensive, and it could be used here on Earth as well.
And last thing, what are those materials that it's made of, and what are you using to represent urine in the experiment? Because I understand actual urine is not being used.
That's true. We use a lot of titanium in our system because of the corrosive properties and to reduce the weight. We are not using urine in this flight experiment. We are using a water that's chemically treated so that we will be able to compare that to urine and see that it operates the same. We're running ground tests with the same water so that we can compare directly how it operates in space. But it's a water treated with some chemicals to mimic the urine.
This is Marcia Dunn, the Associated Press. Following that up, why aren't you using actual urine? Why not?
Well, to use the crew's urine while we're on orbit, we would not be able to collect enough urine to prove our hardware works well. To fly urine up was going to be a little more difficult because of the safety issues that would come up with having urine that had been stored for quite a while to be flown up. And our experiment did sit for a little while on the ground before it flew up, and we didn't want to take any chances that urine sitting for a while before we flew it would cause us any problems. So we just thought the easiest and safest thing would be to fly the water.
Thank you. And Phil, a couple questions for you. Could you give the range of temperatures you've experienced in the space hab, please, from before when this problem hit until afterward, until now with some of the cooling in place?
Sure. Normally we run the cabin atmosphere temperatures throughout the vehicle at in the range of 72 degrees. The crew has a little bit of adjustment capability for comfort level. After this problem materialized, the space hab ambient temperatures peaked at, I believe, about 84 degrees and then started to fall back after we adjusted the temperatures of some of the loops so that we could flow air across the heat exchanger again without getting condensation. We've managed to get the temperature back down to about 76 degrees just before I came over here for the conference.
Thank you. And I heard Rick Husband reporting last night that it was very cool in the flight deck, comfortable in the mid-deck, and of course warm back in the hab. First of all, why would there be such extreme differences in three different areas? And if that's the case, wouldn't it be prime territory for a crew member to get sick with a cold up there going through such extreme changes?
Well, I can't really speak to the crew getting a cold. I'm sure there are other factors involved there. The technical reason for the difference in temperatures is that primarily the air exchange between the space hab and the orbiter is with mid-deck air. Essentially, we draw in air, run it through the heat exchangers, and send it back to the space hab, and then the return air comes down through the tunnel. So you're taking the orbiter air that has just been chilled by the heat exchanger, and some of that comes out in the mid-deck, some of that comes out through the systems into the flight deck, and some of it goes directly into a duct that gets pumped straight back into the space hab where it mixes with what is now warm air back there because of the reduction in cooling. And then for every pound of air, so to speak, that we put back into the space hab, a pound of air comes back through the tunnel into the mid-deck. So we're continually mixing warm air back into the mid-deck. Less of that air tends to migrate up to the flight deck. Another part of the problem is the amount of equipment that's running. We've sized the cooling systems and air ducts on the orbiter to account for the large amount of equipment that we might have running during ascent or during various other phases of the mission, like rendezvous, where we have a lot of computers running. But for a mission like this, where we're basically flying in a stable orbit and actually in a fairly powered down configuration, it tends to make the flight deck somewhat overcooled compared to the mid-deck. So you get three zones, so to speak. A very cool flight deck, because we have essentially turned the temperature control in the orbiter down, but then we have the warm space hab that has some limited cooling, and a pretty comfortable mid-deck because we're mixing that warm space hab air with the cooler cabin air from the orbiter.
Thanks. Do you know how cool it got in the flight deck last night?
Unfortunately, the way our temperature sensors work, we pretty much get the mid-deck temperature, and we don't have real good insight. So most of what we get is subjective judgment from the crew, what the temperature is. We do have some little meters, like a voltmeter with a temperature probe that we can take up there, but it varies a little bit from spot to spot, and there's really not a lot of scientific value in doing that. If the crew says it's cool, then it's cool.
Thanks. And what was the one lost science that you mentioned that you'll pick up tomorrow? I wasn't sure which experiment that was, and I'm wondering, I'm still unclear, did you say that you think this solution in place now will be okay, or are you considering or going to put in place one of these actual repairs where you actually get your hands on these separators?
I believe VCD had a data take scheduled for today that they were unable to do because we didn't have the cooling in place. Their next scheduled opportunity is tomorrow, and assuming that this water diversion repair that we're going to do works as we expect it to, they should be able to operate tomorrow, and we should be comfortable in that configuration for the rest of the mission. It shouldn't compromise any of the science, and we should be able to accomplish all of the objectives. We're also hopeful that we will accomplish all of VCD's planned objectives by the end of the mission, either by recovering the run that they missed today or by taking advantage of their other opportunities to collect any data that they might have missed today.
I guess I'm still a little confused. Does this water diversion plan involve taking up the space hab floor and actually looking at what might be wrong with these separators?
The separators themselves, essentially we're going to open the floorboards, and there are some manual valves in the system that are used to balance the water flow from one part of the cooling loop to another part of the loop. It's a little hard to describe without a drawing, but it's not as simple as just a water loop going from one place to another. There are warm zones and cold zones and valves that adjust the amount of mixing of warm water with cold water going to this loop and warm water with cold water going to that part of the loop. And basically we're going to get in there and adjust those manual valves just a little at a time to try to keep the balance of temperatures where we want them to, but to increase the amount of cooling that we're getting to the payload experiments without overcooling the heat exchangers, so that we don't get condensation when we blow air over the cabin heat exchanger. That's sort of the tricky part. We want to provide more cooling to the experiments, but not more cooling to the cabin heat exchanger.
Hi, it's Chris Kreidler again. How are things going with data transmission from the shuttle? Are you having to do any workarounds, or is everything working smoothly now?
We're essentially in the same configuration we were in last Friday. We get the data to the ground. We do have a problem that we haven't been able to overcome with a periodic crash of the system that's processing some of the space hab data. We know pretty much when to expect it and can anticipate it, and we've taken some precautions to minimize the effects of it, but we haven't been able to keep it from happening. We do, however, have the capability to record all of the data, and nobody's actually losing data as a result of these. We're able to recover all of the data. It's largely an inconvenience at this point, but it isn't costing us any science.
And last question from me. We found out yesterday that Dave Brown managed to capture a lightning elf from space, and I wondered if there had been any other gee whiz moments like that, or what's the crew's mood right now regarding the science?
I think the crew are very happy. Kelly Beck actually spoke with the crew directly yesterday, the lead flight director. They all seem to be very happy with the conduct of the science, with the interaction between the crew and the ground. The capturing of the first ELF from space, and we were joking in the control center, was kind of a big thing. I'm not aware of any other really major firsts so far in that regard. Perhaps our scientists have had some aha moments that they'd like to tell us about, but that's the only one I think most of us are really aware of in the flight control team right now.
Marcia Dunn, Associated Press. One last question for you, Phil. Are you aware of any condensate that did form back in the space hab as the temperatures rose?
No, as I said, the first failure that we had, rotary separator number 1, was due to flooding, and when we got into the floorboards, we mopped up an estimated 2 quarts of water in that incident before we switched to rotary separator 2. When we had the second problem, it was theorized that it might have been due to some amount of water. We don't see any water. And as a result of part of our reconfiguration, we wanted to make sure we weren't getting additional water under those floorboards. So we did do an inspection. I'm going to say it was about 12 hours ago right now. I don't have the exact time. But the crew reported only just a few drops of water. It's hard to say whether that's new condensation or water that's migrated out of locations from the first flooding incident. But we don't believe we're accumulating any significant amount of water under the floor now. And the crew is going in and doing periodic checks and wiping up anything with a towel that they do see.
All right, that's all the questions down at the Cape. Back here for follow-ups, Mark.
Yes, Mark Carruth from Houston Chronicle. I had a couple of questions. The first one was for Phil Engeloff, just to kind of see if I follow the strategy here. Is the kind of the strategy with the cooling system to keep the instruments warm so you can do all the science and let the cabin temperature rise a little bit if it needs to, or is it the strategy that you think you can manage both so that it doesn't get too warm or too cold somewhere?
We think we can manage both. Right now, as I say, we're in a comfortable configuration from a cabin temperature and crew comfort level. We think there's a possibility that we could actually improve that just a little bit by lowering the temperature of the water in the loop. And the trick there is to not make the water so cold that you get condensation. And we think we've got a few degrees of temperature margin to play with between the dew point of the air and the temperature of that loop. But as I say, for the moment, we're comfortable in that category. The problem is that part of that water also goes out and cools the experiment, and that's where we have sort of a shortage right now of cooling to be able to run all of the experiments that we want to at one time. So the real strategy here is to try to increase the cooling to the experiments without increasing the cooling of the cabin air to the point where we run into a condensation problem.
Okay, thank you. And I had a question for Dr. Faith. I know you've done these experiments in the past on shuttle missions and so forth. Does the industry, the automobile industry, in a larger sense, the heating and cooling people, does any of this get passed to them so that they can actually look for improvements in either the production or the operation of their equipment? I'm just sort of wondering what kind of success you've had at sort of handing off the findings you've made and are making to improve this combustion process and lower the soot production.
I'm in aerospace engineering department. My contacts in the industry tend to be in those fields. And actually, we are in pretty good conversation with the aircraft engine manufacturers in the U.S., which have some really taxing particulate emission requirements that are coming up. I think what's been done is that the work that we've done have really helped to explain to them how certain things done empirically, as engineers modify things, have improved soot. And I think now with this the new insights that they have, at least that's what they tell me, they feel that they can kind of manipulate the system in a more reliable way to further reduce those soot properties. I think the other one that most of us know about, of course, is the diesel engine industry, and since I'm at the University of Michigan, we also tend to be relatively close to various engine manufacturers in that area. And certain findings that or some of the findings that we've made also begins to tell you how you want to carry out atomization in the diesel engine or in another liquid fuel burning engine to minimize the formation of particulates. And actually, similar tricks hold to a certain extent in conventional spark ignition automotive engines that burn gasoline. I think the insights that we're getting is that you can manipulate the mixing patterns, and that one example I tried to give you, in such a way that you can take a flame that would be brilliant yellow, burned the conventional way, and turn it from brilliant yellow to blue. An example of how that methodology can affect the practical device, those of you that are my age anyway, can probably remember that early aircraft engines like the Boeing 707 were tremendous soot producers. You could feel, you could almost walk on those plumes as the plane took off. And then really NASA research or development work during the 70s came up with modified ways of injection of the fuel that have resulted in the kinds of exhaust plumes we have today, which have very little soot in them. I think the things that we're finding out by using these space flames, if you will, now have really provided the understanding of why that system works, and hopefully knowing why that system works, we can make further improvements in the future.
What kind of fuel do you use for the space experiments, and is that representative still of the kind of fuels that are burned terrestrially? I mean, is there a worthy translation, I guess what I'm asking, between what you're using as a fuel in space and what you use as a fuel on the ground? The aircraft fuels that are typically used contain the fuels that we use as components of them. One that's very familiar, let's say, to farm families in the U.S. would be propane, which is widely used as a liquefied gas for heating in those applications. The other one is a fuel called ethylene, and ethylene tends to simulate some of the bad actors in practical fuels, things that really produce the bulk of the soot that you encounter in a practical application. For the experiments that we have in space, it really is for accurate metering purposes in the main spacecraft or safety for the astronauts, we really need to deal with gaseous fuels, so that's why we pick on those two. But they are representative, I think, of fuels in general, and we don't certainly our ground-based work has indicated that fuel type has a relatively small effect on these main trends that the experiments I tried to describe earlier have given us.
You're now looking at Mission Specialist Laurel Clark. Clark worked with a wide variety of experiments today, the bioreactor demonstration system, which is being used to grow cancer cells, and also an experiment being used to study how bone cells lose their calcium in space, an osteoporosis experiment. Clark working at this point with one of the video cameras. Clark also did some work with the vapor compression distillation experiment that will eventually be used aboard the International Space Station to turn urine and wastewater into potable water, as well as working with the astroculture growth chamber.
We're looking at experiments in the STARS, the Space Technology and Research Student Boats experiment. This is an international educational payload for students from 6 different countries. Develop biological experiments in order to promote an interest in scientific careers. We're seeing live downlink from Colombia of another run of the MEDEX experiment, the Mediterranean Israeli Dust Experiment. This run's being done over the Mediterranean Sea, and it's looking for dust particulates, aerosols, in the atmosphere produced by dust storms over the Sahara Desert. These aerosols, or tiny particulates, impact the climate in ways not fully understood. This experiment is designed to gain information about their effect, whether, for example, they reflect or absorb heat from the sun, and just how they impact the hemisphere's climate. And now we have a live downlink from the Space Double Research Module in Colombia's cargo bay. This is submission or Israeli payload specialist Ilan Ramon on the right. With Colombia pilot Willie McCool just dismounting from the exercise device. Cool up a little bit late. Work in this video coming down to us now from Colombia involves the ARMS experiment, the Advanced Respiratory Monitoring System, European Space Agency series of experiments looking at changes in the body in response to the zero-gravity environment. Mission Specialist Kovna Chavla here in the right part of your picture. She's been working with the softball experiment. That experiment designed to measure low-intensity flames about 1/50th of the intensity of a birthday candle.
Colombia, we are set up with a PAO camcorder, and you should be able to pick that up. Just let us know.
And Casey, we are on board and have a nice view.
Great. And South Colombia will go ahead and begin the softball test sequence, if that's okay, and hold when we are supposed to.
That's affirmative.
Just wanted to let you know if you can see the corner back where Elon and I are. It's a real busy corner. There's a lot of payloads back there. We have to get in and out of the TEM, the TEHM, which is right behind Elon, and that's where the bulk of the CM2 work goes on. So it's a busy little corner.
Thanks for orienting us there, Laurel. Appreciate it.
This is Mission Control Houston. You're looking at live video from the Space Hab Research Double Module in the Columbia Payload Bay, watching Israeli payload specialist Elon Ramon working in the maroon shirt, and mission specialist Laurel Clark, both of the red team, finishing up their activities for the day. You can see what a busy and crowded place the Space Hab Research Double Module is, jam-packed full of experiments from more than 70 international researchers.
In Houston, Columbia.
Go ahead.
Yeah, are you guys still in the module?
I don't know. It depends on what you're going to do. We're with you.
Okay. Well, Elon just reoriented the camera so you can see the part of the forward Space Hab module where we do the arms runs. Dave spent all day yesterday doing that, and Elon did the same today. Mike will spend the bulk of his day doing that today, and I get to do it tomorrow. It's a great little setup over here in the corner.
Great, Laurel. Thanks again for showing us around.
Okay, well, good morning or good evening as the case goes for all you guys working around the clock there in Houston. Red Shift is just finishing up their day. Blue Shift is eagerly awaiting their flight day 9. Dave Brown, our expert camera operator, videographer, is operating the camera now. So I guess, I don't think you've seen much video of the forward part of the module because the view is better toward the back when the camera's mounted. In the forward part of the module, to the right, as you're facing the front of the orbiter, starting up here, we have one of our fresh lockers. There's actually 3 fresh lockers altogether. 1, 2, 3. Get my crew notebook out of the way. We also have the arms modules that power all the electronics of the arms ergometer payload. That's Advanced Respiratory Monitoring System. Yeah, you guys saw the ergometer a little bit earlier when I was setting up the software. As I said, that's been pretty intensive ops for the last 2 days for all 4 of us payload crew members. Let me see. Anyway, this is all the arms hardware over here. You can see there's a bag where we had the ergometer for launch over here. Can't see it. Okay. And working our way up here, again, we're on the forward bulkhead of the Space Hab module. Okay, sorry. We have our Misters payload up here. We have the Misters payload. We have some of our electronic data management system here. And working our way over to the port side on the forward bulkhead.
It looks great, Laurel. Just to be advised, you have about 2 minutes of video left.
That's the copy sports. We've got our Fab 4 centrifuge over here. We've got a bunch of stowage. You can see as you move your way back on the port side of the module where all the VCD pieces get stowed, and that's also where we do the bulk of our Fab 4. We'll give you some more footage at another time. We hope you guys have a great evening.
Hey, Laurel, thanks a lot for that tour. That music for Dave Brown. Burning down the house, and Dave, your house is safe. We don't want you to think that it's not. We hope you guys had a restful sleep, and we're looking forward to working with you today.
Talking Head says we're doing quite a bit of combustion research up here, so we hope not to burn down either my house at home or anything here on the shuttle, but we are going to be doing a lot of burning and hope to make a lot of contributions to combustion science today.
This is Mission Control Houston, now with a live view inside the Space Hab Research Double Module. The Space Hab module is located in Columbia's payload bay and is a pressurized module accessible to the crew from a tunnel that is attached to the middeck of Columbia. Currently, the blue team crew members are on shift, while the red team crew members are scheduled to sleep for now until they are awakened at 2:39 a.m. Central Time to begin their Flight Day 9. The blue team about halfway through its Flight Day 9. Payload Commander Mike Anderson just completed a status check inside the Space Hab module. It's now moved on to the shuttle middeck for a status check there.
Columbia Space Hab talk for Dave. No need to respond. Just wanted you to know that we are taking in-cabin video.
Hi, Laura.
Hi, Dave. Good morning.
Well, Laura, I'm ready to pick up with softball power down.
And we copy. Thanks.
Houston, Columbia for Seoul.
Go ahead.
Ken, as we experienced previously, it's taking quite a while for lore to command over to science. In their interim, I'm wondering if I can go ahead and proceed with door opening. Soul is in science mode.
Willie, you have a go to open the door?
Here it comes.
This is Mission Control Houston. We're seeing downlink from Columbia of the roses in the astroculture growth chamber aboard Columbia. This experiment seeks to determine the effects of growth in microgravity condition on plants and the oils and flavors that they produce. This experiment is from the Wisconsin Center for Space Automation and Robotics in Madison. Columbia traveling at about 5 miles a second, now moving out over the southern coast of Spain, out over the Mediterranean. This ground track will take it down across northern Africa. Now we're beginning to see some downlink from the MEDEX experiment as this data take is underway. In this ground track, we'll take the orbiter down over northern Africa, roughly paralleling the Mediterranean coast, then moving down across Libya, across the Sudan, and then out across the Red Sea. We'll just cross the base of the Horn of Africa before moving out over the Indian Ocean.
Talk for the module. We see you.
Welcome aboard, Brad. We are happy to have you here, very much like we've always trained with you guys.
And we are happy to be watching you.
And Park Columbia, the 5 minutes are past. What would you like to do?
Casey, we would like you to proceed to step 45 to end this test.
Copy, step 45, end test.
Floating in the center of your screen is Israeli payload specialist Elon Ramon. And just out of the screen to the right corner, and now coming into view, is the commander, Rick Husband. In the back corner in the white shirt is mission specialist Kalpana Chawla. She's working with a softball experiment, creating some flame balls in space. You can see another view here of Kalpana Chawla, again working with the combustion module there in that corner, working on the second of 3 experiments that are going to be done in the combustion module during the 107 mission. During an earlier run today, Chawla was the first person to ever initiate a methane flame ball in space, the crew having quite a few firsts with this experiment. They set a new record for how long a flame ball could burn of 1,200 seconds the day before yesterday with Dave Brown. He also had the lowest powered flame ball ever recorded, just about 1/2 of a watt. Commander of the mission, Rick Husband, seen here in your center of your screen. Husband, a member of the red team. Husband spent his day doing various maneuvers with the Space Shuttle Columbia, maneuvering it into a free drift position for the softball experiment so that none of the reaction control system jets would fire while the softball experiment was going on. He also replayed some of the MEDEX data that had been taken by the blue team earlier in the day. He then maneuvered the orbiter into position to get some data for the shuttle ozone limb sounding experiment, which is looking at a new instrument for measuring ozone in the Earth's upper atmosphere. The red team seen working here, coming toward the end of their day in space, their 9th day in space. In about an hour, they're scheduled to do a handover with the blue team, and the blue team will be taking over to do its scientific research for the evening.
Now here's Casey looking out the window and discovered that she's looking actually at the Gulf of Eden on the tip there. And now we are looking at Dave Brown in his studio. We, the 107 crew, have to thank very much Dave Brown for his magnificent work of the video and photo of our whole mission. And he's working like crazy to get everything documented. And hopefully you'll be able to see and watch a lot of it. He's sitting right now, okay, he's actually getting ready to bed. So here's Dave brushing his teeth, making the last preparation to go to bed. And here's the toothpaste floating there. We
inside your mouth. And here's Dave getting into his bunk to sleep. That's the bunks we use for sleeping. We have sleeping bags inside, and bye-bye Dave, good night. Closing the door because we operate 24 hours a day, and we have to continue operate. And now we're watching Laurel Clark in her BDS-05 bioreactor development system, which is actually prostate cancer research of the University of Virginia of Professor Leland Chung. And Laurel actually is transferring fixation to the cells right now. We need to work in inside Ziplocs so that no spills are coming out. And this is the actual bioreactor. It's a little bit hard to see, but the cancer cells are growing inside there in a zero-G environment. And here is Ilan Ramon from Israel conducting the STAR experiment, which is a student experiment. In a second, you'll see the experiment module. Right now, Casey is trying to capture some Earth orbs with our cameras out of the window, and I think we'll be going over Africa. And here's the back side of the orbiter, looking at Africa, at the Tagana Desert, and here in a minute we'll come to Lake Chad. This is Lake Chad under the back of the orbiter. And back to the START experiment. This is a student educational experiment, and here we're looking at silkworms, and it's hard to see, but we have one that hatched actually, and it's a butterfly there, and the silkworms are from China. On this experiment we have actually 6 experiments. The silkworms come from China. We have a medaka fish from Japan. We have bees from Liechtenstein. We have the chemical garden from Israel. And we have spiders from Australia. And we have a space biosphere from the US. It's a great educational experiment. And it influences and inspires students all over the world. Here I'm trying to capture some of the web of the spiders from Australia. This is the inside of the STARS module. It's a little bit tough to see. And here's Rick Husband, our commander, in the BRIC experiment. The BRIC experiment is out of Ohio State University, and it tries to understand the orientational and distribution of the tips of some cells. Rick uses a special gun to fixate
after some time. And here are the two guns in the hands of our commander, our great commander, Rick Husband. And back to Laurel, she is conducting the osteo experiment. We have two experiments on board, the osteo and the aristo. The osteo comes from Canada, the aristo from ESA, from Europe, and they both investigate bone cell loss, which is actually the cause of osteoporosis on Earth. Here in space, there's a lot of bone loss, much more. And that concludes our daily crew choice video. And you could see we have a lot of experiments and science internationally and educationally on board.
Lon, that was an awesome video and great narration. I don't think Tom Cruise did as good a job on the ISS video that was done in 3D, so we appreciate all that effort. I know it takes a lot to put a video like that together, but it was very helpful for us on the ground to see what you've been doing.
Thanks for the great words.
Columbia just crossing the U.S. East Coast. The spacecraft is about 168 statute miles above the Outer Banks of North Carolina.
Looking at live video from the SpaceAb Research Double Module. Dave Brown of the blue team floating into view wearing the tan shirt. Wearing the dark blue shirt is Israeli payload specialist Ilan Ramon. Payload specialist Ilan Ramon working over in the area of the combustion module. That combustion module, the site of 3 experiments in this mission.
Columbia for BioPack, main power circuit breaker, ready, mark. And 1, 2, 3.
Mission Specialist Laurel Clark recycling the BioPack experiment, a suite of experiments by the European Space Agency.
Columbia, I've done the 30-second hold, and I've let those switches go back to their middle position.
And Laurel, we copy and appreciate the extra effort.
No problem. We're standing by, watching her, and keeping our fingers and toes crossed.
We're doing the same down here.
The freezer of the BioPack's been acting up, and they think that by cleaning the filters and doing some other bits of work on the BioPack, they can get that freezer back online.
And Park Columbia for ASD.
Go ahead, Casey.
Yes, that the ASD download is complete.
Thanks for the status. We appreciate it. Have a good rest of the day.
you too.
Mission Specialist Cotton Chawla reporting that the astroculture growth chamber data has been downlinked. That experiment is finished at this time. They took 4 samples from the 2 plants that are growing. This research being done in hopes of developing a new fragrance for use here on Earth. Now in view in the Space Hab Research Double Module is Mike Anderson.
We copy, Casey.
Israeli payload specialist Ilan Ramon now floating into view. Ramon spent the majority of his day working with one of the combustion experiments, the softball experiment, looking at igniting flame balls in space using very lean fuel mixtures. Two members of the blue team now in view. In the center of your screen is Dave Brown, one of the mission specialists who will be working with the softball experiment today. And at the far wall is the payload commander for this mission, Mike Anderson, and he'll be working with the mechanics of granular materials experiment. Anderson will also have an opportunity to work with softball in the afternoon.
The rack is still running, but the VIP fan has not yet come on.
And Laurel, we copy, and that's nominal.
I understand. I was just giving you an update.
Thank you.
And Beth, do you want me to stay here and monitor this, or would you like me to go back and do my MPFE check?
And Laurel, you have a go to do your MPFE check. We appreciate the help with BioPack.
No problem, and Willie's going to stay here. He's thinking in positive thoughts as he gets ready for the day.
That's great.
Payload commander Mike Anderson floating into view of the camera, then floating out of the bottom of the picture. Mission Specialist Laurel Clark of the red team now going off to check the microbial physiology flight experiments. It's 2 experiments together that are looking at the effects of microgravity on the physiology and sensitivity to antibiotics of bacteria and yeast that are growing in microgravity.
In Houston, Columbia, galley morning config is complete.
Thanks, Casey.
That was Mission Specialist Cotton Chawla, known as KC, who floated through that view. Correction, that was Mission Specialist Laurel Clark.
And Park Columbia for MPFE. The unit is happily reading a set of cards. I'm going to go ahead and start the module status check, and I'll do the actual incubator temp check for you later, but everything looks good for now.
Okay, Laurel, we copy. Appreciate that.
Mission Specialist Laurel Clark working in the rear of the Space Hab Research Double Module. You can see her here wearing the blue shirt against the far wall. She was checking out the microbial physiology flight experiments, which is looking at how bacteria and yeast grow in space, and also whether they become more insensitive to antibiotics. Floating now toward the rear of the Space Hab Research Module is Israeli payload specialist Ilan Ramon. Ramon and Clark both on the red team. In the center of your picture is Dave Brown of the blue team. Red team beginning to finish up their day while the blue team just begins their 11th day in space.
It's been almost 10 days since STS-107 launched from Kennedy Space Center, and we're up here working round the clock on several different science opportunities. These are two video tape recorders that we use in the cabin to record MEDEX data. Here's Dave Brown at the aft station working the MEDEX payload, where he's doing some observations looking for dust. We're looking for dust primarily in the area of the Mediterranean, and certainly we've got a great picture here of Egypt and the Sinai Peninsula, and up at the upper left part of the screen, Israel. We've zoomed into Israel here, where our world-famous astronaut Ilan Ramon is from. And he zooms in on this picture. You can see the Dead Sea to the right, and there just about in the center of the picture is where Jerusalem is located. As we back out, you get a good shot of the Red Sea down on the lower right part of the picture. And as we take a look down at the southern tip of the Sinai Peninsula, we will zoom in and we'll see the areas of Ras Nasrani, where it's very good scuba diving, I'm told by Ilan, is to be had by all. And as we work our way up the coast here, we'll see the area where Sharm el-Sheikh is located, and as we work up to the north end, we see where Eilat is located, the southernmost city in Israel. Next, we'd like to show you a lot of things about what we do living in space. Here is KC, not too long after we have, the redshift has woken up, going through the execute package. We use her excellent organizing skills to help get that stuff put together, and then she and I sit down and review it before we start our day, and Blue Shift does a similar operation when they start their day. Here we are traveling from the airlock of the orbiter through the tunnel into the Space Hab module, and you can see Ilan here doing some space acrobatics in the module. And I think the cameraman did a few as well. Here comes the Superman entry of the astronaut from Israel, and Ilan has done such a fantastic job up here. It was a great thing to be able to give him a break and have some fun. You can see him doing a nice little pirouette, and then taking some time to have a snack that he's brought up. And you can see how the fact that we're in microgravity with things floating like they do make eating a whole different experience. Additionally, here comes Willie McCool, the pilot of STS-107, coming into the module. He's here to do some house cleaning duties, and we have both in the module and in the orbiter trash bags that we have to empty out every day. And here we'll see Willie as he removes the dry trash from the bag back there in the Space Hab. And after he gets that trash bag out, he'll be turning into a human trash compactor to roll that bag of trash up into a ball that's small enough for us to put in our trash stowage area. You can see Willie puts his superior strength and skill to work here on this trash bag, and really puts forth the effort in everything that he does. So we get the thing down compacted about the size of a football, and then we use the probably one of the most important things that we have in space, and that's gray tape, without which we would be just about lost from the standpoint of living. Once we've emptied the trash and had dinner and everything's all squared away, it's time to crawl into the sleep station. Willie's ready to go. And so He's crawling in to his sleep station. He's got sleeping bags inside there, and in the meantime, Laurel decides she's going to check out her sleep station as well. Inside those sleep stations, we've got some pockets on the far side that we can put clothing or books or anything we need. We've got a light in there that we can use to see what's going on. We've got some straps on the sleeping bags that allow us to kind of hold ourselves in place. You can see Willie there's got his head strapped to his pillow so he can feel like he's laying in bed at night ready to get a good night's rest. Here KC is preparing breakfast at our galley. We have what is called a rehydration station. That's just a fancy way of saying that you're going to put some water into this dried food and get the moisture back into it again. We've got these vacuum-packed plastic bags that the food is sealed in. This looks like she's got some granola with blueberries here that she's preparing for breakfast. Once we let the water soak back into the food for 5 to 10 minutes, then you can cut the package open with a pair of scissors and then eat it with a spoon usually. Now here we have the red shift and the blue shift all on the middeck during our handover before the blue shift goes off duty and the red shift starts their day. And what we do is we gather, we try and pass on what we've learned from the previous shift and what the status of the various payloads is. You can see just to the right of the picture is the hatch for the airlock, and certainly another important roll of gray tape. And then here I am, once we've gotten through with the handover, up on the flight deck, loading a maneuver. During this flight, we have in excess of 250 maneuvers that we're doing for the various payloads. And our hat is off to Andy Lawlich and his team. He's our pointer that's come up with the attitude timeline for our flight. And he and the FAO Terry Schneider and their team have just done a fantastic job coordinating all the different payload activities and the attitude requirements and such. Here's Dave having the last snack on the middeck before he gets ready for bed. And you can see the scissors, and he's having some dried pears for his snack. Additionally, one of the things that we have to do is to change out the what these are called lithium hydroxide canisters. And what these do is they remove carbon dioxide from the atmosphere. So we have kind of a closed environment here. We've got fans that move the air around, and every day Willie takes these canisters and changes them out with the previous day's canisters so that we can make sure that we keep the air in here at a nice breathable level for everybody. This location is in the middeck floor where the LIO canisters are located, and we turn off the cabin fan to stop the airflow, swap out the cans, make sure that the doors are good and locked, and then we turn the cabin fan back on to start the air circulation again. And one of the things we get to do that's very enjoyable is to look out the window. Here's a beautiful view of the Earth as we come and make landfall over the continent of Africa in the vicinity of Morocco. You can see the Atlas Mountains there about the middle of the picture. And as we coast on past those, you see the beautiful desert scenes that we get from northern Africa and the Sahara area. And we'd like to thank you all very much for all the support that we've gotten and all your interest in the flight and all the great work from the folks on the ground. And this will conclude the crew choice of STS-107.
We are looking at you and Elon.
Oh, great. And if you like, we can show you some of the connections for which Antil's heart is probably beating very fast right now.
I think he would love it.
Okay. The gas line the metal-to-metal contact was felt here where my finger is pointing. The clear GC line, you can see it routing, and you can see where it's connected to the EMS. Is Anhil getting a good view, or does he want a more close-up?
And I'm told that they are getting a beautiful view.
And we are right now in step 22. Or actually, let me just verify 1 second.
Kalpana Chawla taking us on board the Space Ab Research double module. We're looking at work with the CM2, the combustion module 2 facility. She and Israeli payload specialist Ilan Ramon working to set up the first run of the MIST experiment. The experiment designed to see how mist can contain or extinguish flame, water mist.
We are at step 25, and if you have any other requests from Anhil to, say, get a good front view of the EMS or any of the other connections, we can do that. From this angle, he cannot see those valves MV01 and MV02 that we turned on the other side, but Ilan's been working with me, and we've been verifying very closely that everything is done as called out.
The MIST experiment is the last of 3 flame-related experiments to be conducted in this combustion module 2 facility.
And he said everything looks beautiful and just proceed.
From Mike Anderson and Dave Brown, and the Anhil song is going on here.
And Anhil says to send you all a big hug.
Copy, and Anhil, you cannot believe this is happening, but here we are, and the EMS is almost ready to go in.
A moment ago, we were seeing Dave Brown and Mike Anderson, the mission specialists from the blue team. Now we're back with Ilan Ramon, the Israeli payload specialist, and Kalpana Chawla, the mission specialist of Columbia, working with the CM2, the combustion module 2 facility, getting ready for the first run of the MIST experiment. MIST is more formally named Water Mist Fire Suppression Experiment. It's an experiment from the Center for Commercial Applications of Combustion in Space from the Colorado School of Mines in Golden, Colorado. And its purpose is to try to better understand how water inhibits the spread of flame. Possible application would be in development of improved, lighter weight fire suppression systems capable of extinguishing flames with perhaps not quite so much damage as conventional firefighting methods sometimes result in. Such systems also are believed to have potential space-based applications, and they wouldn't require ozone-damaging chemicals like halons. Two previous flame-related experiments have been completed in this facility in the combustion module facility. The first was the laminar soot process experiment designed to understand more about the production of soot in flames. That process and many other processes relating to flame can be better studied in space, where flame behaves differently. Flame not only is shaped differently without the convection common on Earth, but it burns more slowly, giving investigators a chance to make perhaps better observations. The second of the experiments was the structure of flame balls at low Lewis number, or softball experiment. That experiment was designed to improve the understanding of lean combustion to help engineers perhaps design internal combustion engines that operate more efficiently and with less pollution.
In this now live video from inside the combustion module looking at the flame balls that Payload Commander Mike Anderson has ignited.
And that's for CM2. This is a tough one. We think we got a whole control room full of flame balls here, so we're going to call this the Orbit 2 flame ball crowd.
We copy, Dave. We can get all those flame balls named in the mission summary that we send up.
Okay, the lead flame ball is named Kelly, though.
Obviously.
And Mission Specialist David Brown continuing the tradition to name some of the flame balls inside the combustion module, naming it after the Orbit Team 2 flight controllers here in the Space Shuttle Flight Control Room. Flight Director tonight is Kelly Beck, and the spacecraft communicator is Stephanie Wilson. This experiment burns extremely lean fuel-air mixtures that are near the lower limit of combustion. This so-called lean burning is better for the environment, but lean mixtures also lead to engine misfiring and rough operations. So the scientists are studying this experiment to hopefully gain more and better information about lean combustion to lead to designing car engines with better fuel efficiency and reduced emissions. This image is being provided by a camera with an image intensifier because the flame balls are invisible to the eye. They're being viewed in this combustion module in the dark with this special camera so that they can be captured. Data from this experiment may also be used to protect future spacecraft from fire by determining flammability limits in microgravity. And it also might provide a better understanding of premixed gas explosions in confined spaces, such as those that occur in underground mines.
Good morning, Houston, and that's a wonderful song. Ready to start off another wonderful day in space. And just like to thank my wife and my two kids for all their support for this flight. And we're ready to get busy on another day in orbit. Thank you.
Camera in Columbia's payload bay, just looking down over the Houston area as the spacecraft completes a run over the southeast Texas coast.
This is Mission Control Houston. You're looking at live video of Kalpana Chawla working in the Space Hab Research Double Module with the combustion module. She's working on a procedure to try and get the MIST experiment back online. That's an experiment that's going to use the combustion module to study using water mist to put out flames. The MIST experiment did fail a leak check yesterday, and engineers on the ground have put together a recovery procedure, and Chawla continued to move through that procedure.
JALA pulling out the experiment mounting structure, or EMS, from the combustion module. This is again part of the procedure to try and recover the missed experiment that's going to be using the combustion module.
Copy, Brad, and you're welcome anytime.
Here in Mission Control Houston, this is a very common sight for every mission. Every mission, in fact, since STS-107 in September 1988. These flowers have shown up here in Mission Control. They're sent to the Mission Control Center by the Shelton family in Bedford, Texas, which is near Dallas. They've been sending them since STS-106, which is the first flight after the Challenger accident. They send one red rose to represent each member of the crew, and one white rose to represent those who have given their lives in space exploration. Earlier today, there was a moment of silence here in Mission Control at 10:39 in honor of the Challenger crew and also the honor of the Apollo 1 crew. This gift from the Shelton family is always much appreciated by the controllers here in Mission Control, and that they remember not only the crews who are on orbit now, but those who have given their lives for their country.
This is Phil Chen of Earth News for Willie McCool. Every astronaut gets asked thousands of times, what's it like to fly in space? And now that you can finally answer the question, what's it like to fly in space? And have you had a chance to look at your hometown of Lubbock, Texas?
I'd liken it to a smorgasbord of new and invigorating and sometimes fun and sometimes not so fun experiences. All in all, it's just been overwhelming. And in answer to your second question, every time we go over the U.S., our shift unfortunately has been asleep, so we have not seen anything except the far east coast of the U.S. on the early portion of our mission.
And for Alon Ramon, same question. What's it like for you, and have you had a chance to see Lubbock, Jerusalem?
Well, it's great to be here in space. I wish I could go again and again. Although I want to come home, I miss my kids and wife. And it's even greater to fly over the U.S. and Israel. The world as a whole looks marvelous from up here.
Thanks. And a question for Colonel Ramon, if I could. You know, on flight day 3, I asked you if you'd had a chance to reflect on the historical significance of your flight, and you said you'd been pretty busy and really hadn't had a chance to think about it. I'm just wondering, have you had time to think about it a little bit now as you've flown over Israel a couple of times? I mean, what you think about the historic significance of your flight?
Yeah, first of all, I think that flying over Israel is great. To see your country, your state from up there so calm, so nice, so neat is really great. And I wish we will have very soon the quiet and the peace and the peaceful we see Israel and the Middle East from up here down there.
For Alon Ramon, have you had the results you expected from the MIDEX experiment in terms of viewing dust aerosols in the atmosphere?
Well, Chris, in the first 7 days, I believe, we didn't have any dust up in the atmosphere, but it looks like they waited until my shift, and we had a big storm, dust storm over the Atlantic, which lasted about 2 or 3 days. So I think the scientists are very, very successful with their experiments. Other than that, we had another quite big experiment with a MIDEX payload, which is called Sprite, which are actually lightning that are going up from the top of the cloud to the atmosphere, and we had a lot of lightning storms recorded.
This is Phil Chen again. Sorry to accuse you, Willie, but I guess the PL misidentified you earlier on in the mission. For Alon, you told us before that on your first Sabbath in space, obviously it was just after launch, you weren't able to do anything to commemorate it, but how about your most recent one a couple of days ago, or the one that's coming up in a couple of days? I believe you're on Houston or KSC time. Have you been able to at least pass around a Mylar bag of imitation and grape drink since you don't have any wine up there?
No, unfortunately, or fortunately, when you are in space, you lose the days down on Earth. So actually, if you ask me what day is it for you guys, I have no clue. I know that we are on flight day 14. That's what I know. But I think that I will catch this Friday, which is the last Friday for us in space, and try to do something. And by the way, the one thing that I do is eat kosher food up here, which was provided for me by NASA. And actually, my crewmates share with me and love it.
I'm pretty certain today's Wednesday, but I wouldn't swear to it because I'm also on mission lapse time. And Alon, I've asked you quite a few questions during this mission, but is there anything that you want to say to the people of Israel? What do you want to tell them about your mission right now?
I would like to say to the people of Israel that the world looks marvelous from up here, so peaceful, so wonderful, and so fragile. The atmosphere is so thin and fragile, and I think that everybody, all of us down there, not only in Israel, have to keep it clean and good. It saves our life and gives our life. And for the people of Israel, I wish, as I already said, I wish we will have a peaceful land to live in very soon.
One day I was in the flight deck looking from the overhead windows outside, and it was starting to get dim outside, so you start to see your own reflection. And there is the Earth's limb outside. You can still see the Earth's surface and the dark sky overhead. And I could then see my reflection in the window, and in the retina of my eye, the whole Earth and the sky could be seen reflected. So I called all the crew members one by one, and they saw it, and everybody said, "Oh, wow."
Here KC is showing us one of the food trays. These food trays have got 3 meals per tray for 4 people. So this is the redshift meal tray that KC has gotten out, and our undying appreciation goes to the folks who pack and manifest all the food for us so that we have these great meals up here. You can see how the tray is arranged and how you can see things are really packed in here, but you can see some really good stuff like cookies, and here KC's pulling out one of the breakfast items, granola with blueberries. You can see right here on the the left side of the middeck, we've got the galley. We've got the printer there where we print out all our messages that get sent up to us from the ground. And then behind this door, we have the WCS, otherwise known as the bathroom, because this is where we go for our daily hygiene. And you can see there the WCS with towels hanging out from the door, and the different cabinets that we have for tissues and different things like that.
Good morning, Linda. That song makes us think that from our orbital vantage point, we observe an Earth without borders, full of peace, beauty, and magnificence. And we pray that humanity as a whole can imagine a borderless world as we see it and strive to live as one in peace. And with that, Ilan would like to translate in Hebrew.
Thanks, Willie. מזווית המבט שלנו כאן בחלל, כשאנו סובבים במסלול סביב כדור הארץ, אנו מביטים אליכם, ולמולנו נשקף עולם ללא גבולות, מלא שלווה והדר. תפילה בלבנו שהאנושות כולה כאחד תדמיין את העולם כפי שנשקף לנו, ללא גבולות, ותשאף לחיות ביחד, בשלום. ובמילות השיר אתם יכולים אולי לומר שאני מדמיין וחולם, אבל אני לא היחיד. אני מקווה שיבוא יום ותצטרפו אלינו ונזכה לחיות בעולם נפלא.
Well, to Willie and your team, we appreciate all those words, and we wish that everyone down here could have your view of the world that you're seeing from space.
And this live view is of Mission Specialist David Brown inside the Space Tab Research Double Module, which is serving as the laboratory for the 107 mission. He's working with the combustion module, which is housing the water mist fire suppression experiment. The combustion module is providing experiment control, containment, diagnostics, and communications for this on-orbit fire-related experiment. It also provided that information and control for two other experiments before this for this mission. That first experiment was the laminar soot process experiment, which was working to gain a better understanding of soot formation by using the microgravity environment, which slows down the reactions in a flame. And those reactions could be more easily studied while in orbit. The second experiment inside the combustion module for this mission was the structures of flame balls at low Lewis number. And that experiment was working to improve the understanding of lean combustion, which could help engineers design engines with better fuel efficiency and reduced emissions. This water mist fire suppression experiment is studying how a water mist system can put out flames. A thin layer of a flame is developed inside the combustion module, and then a mist, like in a fog here on Earth, would be used to extinguish that flame to study how the droplets interact with the flame. This information from this experiment could be used to determine the optimum water concentration and water droplet size needed to suppress fires using a water-based system. We could possibly use that information to improve models for designing the next generation of environmentally friendly, low-cost firefighting systems that would replace the current firefighting chemicals, including halons, which are actually bad for the Earth's ozone layer.
Of course, we're eating too. Our family loves soup. We eat a lot of soup at home. Fortunately, the food folks have picked some wonderful soup here for us on orbit. This is vegetarian vegetable. One of my favorites. I have soup almost every day for lunch. The packets are sealed. We open them up with scissors. This is pretty much our normal routine for a dinner meal. When you open it up, you have to be real careful that nothing comes out, gets all over the place. I'm going to get my spoon out and take a bite. It really is very, very good. Incredible how they've made the food wonderful here for us on orbit.
finally, here's some tortillas. This is a vacuum-packed tortilla. I'll open it up in a minute. We eat them for almost every meal. We've gone through our fresh food tortillas. They're pretty much like tortillas on the ground, but they behave a little bit differently. They're really good. Here we have the Space Cab choo-choo train coming down the tunnel. It's really fun to, we have to zip up and down here a lot of times today, but today we've got Rick and Casey and Ilan all coming together in a big train. And mostly work's got a whole lot of fun up here. Here's Ilan doing some microgravity circus tricks. You can see the hidden arms from the side to make sure we protect all of our microgravity payloads that we have on board. Of course, our commander couldn't let Ilan show him up, so he's doing some very nice pirouettes here as well. And of course, we're getting ready to go home, so we're doing exercise, and we've been doing push-ups in order to be ready to feel good when we get back to Earth. Push-ups seem a little bit easier here for some reason.
Columbia, this is Houston. Are you ready for the event?
And Columbia's ready.
National Public Radio, this is Houston. Please call Columbia for a voice check.
Columbia, this is National Public Radio. How do you hear me?
National Public Radio, this is Columbia. We hear you loud and clear.
Mike, is one of the 7 active African American astronauts, what do you see as the future of African Americans in space?
Well, that's a good question. I see the future as being pretty bright. As you mentioned, there are 7 of us. Bob Curtin will be flying in just a few months. Then, of course, later in the year, we'll have Joan Higginbotham flying. And early next year, you'll see Stephanie Wilson flying. So it looks like the future is really bright. And not only that, we also have some research that I think will be really beneficial to the African American community. On board this flight, we have a bioreactor, which is growing prostate cancer cells. And as you know, Travis, prostate cancer is a high rate of occurrence in African American males. And hopefully from some of the research we're doing up here, we can really help out in those areas.
Willie, this is your first space flight, I understand. How does your experience compare with what you expected?
There is so much more than what I ever expected. It's beyond imagination until you actually get up and see it and experience it and feel it. So I would say the things that are new to me are the zero-G type changes to my body and the zero-G changes to the things that we do routinely day to day that you can only imagine, but you can't really quite imagine it quite right until you get up and do it.
Mike, you're the payload commander of this mission. What exactly does a payload commander do?
Well, like I show you in the back of the shuttle, you see our laboratory, and back there we have hundreds of experiments, and those are our payloads. So my job is to manage those experiments and to make sure everything gets done properly. So with the help of all my crewmates, that's where we spend most of our time each day in the payload bay working on those experiments. And really the job started well before flight, working with the scientists and engineers and making sure that the payloads were designed properly and that we were going to get the right results on orbit. So far, I have to tell you, we've been really pleased with what we're seeing. We're exceeding almost all of our expectations, and we're getting some really good science.
Willie, I understand you're doing an experiment involving African dust. Now, you got to tell me, what's that about?
Well, believe it or not, there's a lot of dust in the air, and it contributes significantly, we think, to the temperature of the Earth, and it may have impacts on global warming. So we're looking specifically at dust that comes out of the North African Saharan area that migrates across the jet streams, across the Atlantic Ocean, up into the Mediterranean. And we have some radiometric cameras that measure the reflectivity of that dust to see how it reflects the sunlight from the Earth's atmosphere.
Mike, before we began this conversation, I just got off my treadmill. I understand you have an exercycle up there in space, partly to keep in shape, I guess. but also partly to run experiments. Tell me about your extra cycle.
Well, we do try to exercise a little bit every day just to stay in shape, but when we do return to Earth, we'll be able to actually walk off the orbiter. But we're also using that ergometer as part of a larger experiment, which we're really taking a close look at the cardiovascular system of the human being and seeing how it adapts to space and what kind of changes that go on in the body once you do come up into space and how quickly you react when you come back to Earth. So we spend a little bit of time each day cuddling around, and I tell you, there's nothing better than listening to a good album and looking out the windows and watching the world go by while you pedal on the bike.
Willie, I've only got about 30 seconds left here. When you look out the window, what exactly do you see right now, and where over the world are you exactly?
Well, I'm going to lift the lid. Dave's actually going to lift it here. We have a world map display. We're on the dark side of the Earth, approaching Chile, actually. So we have covers right now over the windows because we go from light to dark and dark to light. We don't want to have to create shadows suddenly here in our TV images. So right now, if we were to look out, we'd see city lights of South America.
Thank you both, and enjoy the flight.
Thank you, Travis.
Columbia, this is Houston ACR. That concludes the NPR portion of the event. Please.
Columbia, this is Richard Brown, KXLY TV Spokane. How do you hear me?
Richard, this is Columbia. We hear you loud and clear.
Mike, you're a boy from Cheney, from Spokane. You got any messages for the people down here on Earth who know you?
Well, first of all, I'd just like to say hello to everyone. It's been a while since I've been back there. It's been a couple of years, and still have a lot of good friends there, and I look forward to coming back after the flight and saying hello to everyone and telling them about this flight and all.
Well, Mike, we'd be pleased to have you here. Willie, let me ask you a question. The way you have answered some questions tonight, it appears like you don't really want to come home on Saturday. You'd like to stay up there a little longer.
Well, I'll just tell you what, I can't describe the overwhelming sense of just elation that I feel being up here, especially the views. We've described them to everybody that we've talked with, and they're just beyond all imagination, and photos just don't do it justice. The sunrises, the sunsets, the moonrises, moonsets, going around the globe, seeing the Himalayan range, the Great Barrier Reef, it's phenomenal.
Dave, let me ask you a question about some of the experiments you're working on. There are 80-plus experiments. How are they going?
Well, they're going remarkably well. You know, my background was a medical one, and it's been a real treat as a medical guy to come up here and work on atmospheric research, looking again, as we've heard, about dust and the contribution to global temperature. This afternoon, I'm going to spend in the laboratory module working on a combustion experiment on how to use water vapor to put out fires. So the experiments are going really well, and it's a great treat as a physician, again, to work out of my field and just learn about all sorts of new and interesting things.
Hey, Mike, is the food any better than it used to be a few years ago?
I think the food gets better every time. We have actually a pretty broad menu, a lot of good dishes, and we're really enjoying it quite a bit. And of course, on this flight, we have Ilan Ramon, an Israeli astronaut with us, and he brought along some kosher dishes that are absolutely fantastic. So we're really enjoying the food quite a bit.
Mike, would you consider this to be a successful mission in terms of the experiments you're working on?
I think it's been more than successful. You know, we've had some experiments that have just really done more than we ever imagined they would do, that have really gone beyond the expectations of ourselves or the scientists and engineers who designed them. I mean, some of the results we have are just fantastic. So the mission's been, 100% successful, and we just can't wait to really get home and open up the payloads and let the scientists really take a look at what we've done up here.
Yeah. Have any of those bugs gotten loose? I know you had some student experiments up there with some spiders and whatnot. Are they behaving themselves?
They're behaving real well. As Dave mentioned, we did find one bug, but we think he was still away from Florida. But all the bugs are well contained. They're doing well, and those student experiments, I think, are really generating a lot of interest at schools all around the world. And students are looking in at the video that we're sending down to them and learning a lot about the insects, their experiments, and what it really takes to design an experiment for space.
Mike, before we go, there's a lot of people around here who know you, who know you're from Cheney, from this area, a lot of young people probably watching this interview. Any advice for them who may be considering a career either in the armed forces or as an astronaut?
Well, first of all, I'd like to tell them that if you're living in Spokane and in the Cheney area, you've got some very good schools and some very good programs around there. Take advantage of all of that and learn as much as you can and prepare yourself and take advantage of all the things that Spokane has to offer. And then just apply yourself. Work hard, be persistent, and don't give up, and you can achieve any dream you really want to achieve. And I tell you, I'm having a great time at this job. It's absolutely fantastic. It's what I wanted to do since I was a little kid, and thankfully Spokane gave me all the tools I needed to do in order to achieve that.
Gentlemen, thank you very much. Have a safe flight and Godspeed.
Thank you.
Columbia, this is KFMB TV in San Diego. I'm Pamela Davis. How do you hear me?
Hi, Pamela. We have you loud and clear.
Willie, you're from San Diego. Is it as pretty up there as it is down here?
I have to tell you, we've got you beat up here.
You're kidding. What do you see when you look out?
I see the world in 90 minutes.
More details. Kind of what do you see from the space shuttle there?
The visual images are too many for me to describe. Let me describe to you my first image. After ascent, post-main engine cutoff, the flight deck was still pretty busy circularizing our orbit, and it wasn't until about 40 or 45 minutes after we achieved orbit that I was actually able to unstrap, and I was still very busy, heads down in the cockpit, and Rick, our commander, Rick Husband, said, "Willie, come look." And I came to the back window, and it was dark outside, but the tail of the orbiter we could see, and it was starting to glow, a orange, then a deeper orange, then a red. I'm going backwards. Red, orange, yellow to white. All in about 15 seconds, I saw my first sunrise across the tail of the orbiter.
Wow. Wow. Mike, what is the most challenging thing about living on the space shuttle?
That's a really good question. You know, nothing is really challenging. I think everything just is different. And so you just have to learn how to adapt to all the different things. It's a little bit different going from point A to point B. Instead of walking, you simply float there. It's a little bit different brushing your teeth and washing your face, but nothing is really challenging. It's really amazing how quickly you adapt to being up here. After a couple days, it feels like you've been here all your life.
And so is it more difficult to adapt to coming back?
Yeah, I think so. I think getting rid of gravity is fairly easy. The body makes its adjustments really quickly, but when you come back to Earth, you know, your legs are a little wobbly and you're a little bit dizzy and a little bit off balance, and that's a little bit harder for me to adapt to.
Dave, can you talk a little bit about the mission and what you specifically hope to accomplish up there?
Well, we have four major areas of research. We're doing some Earth atmospheric research, looking at ozone, again, dust and other aerosols and how they contribute to the global climate. We're looking at basic physical processes. We're looking at how flames burn and want to learn more about how to make more fuel-efficient engines, how to make cleaner engines, and even how to put fires out with water vapor. We have some education payloads, which have to do with students. And they can actually get on the internet and watch those payloads as they're downlinked.
Can I talk to
Willie? I'm sorry, and then life sciences. I'm a physician. You think I'd put that first? And we're looking at human physiology, which includes things like osteoporosis, calcium loss, which affects us as astronauts, and so we're being studied. And maybe we can learn something that'll help people on Earth who are at risk for losing calcium as they get older.
Dave, thanks. Willie, was this what you wanted to do when you were growing up here in San Diego?
I think I'm an exception to the rule. I can't say that I had a lot of specific aspirations as a child, and it wasn't until I was at the Navy Test Pilot School when I saw my classmates start to make applications to the astronaut program, I realized, hey, I'm in line to do something that's going to be a whole lot of fun, so why not try it myself? And so it wasn't until I was probably 30 years old that I first had my aspiration to become an astronaut.
Well, thank you all very much for joining us.
Columbia, this is Houston ACR. That concludes the event. Thanks.